All right. So, today talking about the applications of the normal distribution, and I apologize for the lower tech video, but my bamboo tablet and pen are at home because I was not expecting us to need to do this today. So, sorry about that. So, to review, one of the things we talked about yesterday, that when we have a normal distribution, we have a symmetric bell-shaped curve. So our continuous random variable on a normal distribution is capital X, lowercase x being the individual values. In a normal distribution, our mean and median and mode are right at the center, right at the peak. And then our empirical rule applies to our values that are 1, 2, and 3 standard deviations away from the mean. So the first one is mean plus 1 standard deviation, then mean plus 2. Down here, mean minus 1 standard deviation, so on and so forth. So today we're talking about the standard normal distribution, which is a type of normal distribution where the mean is 0 and the standard deviation is 1. So in any type of directions, if it says standard normal, that means mean is 0, standard deviation is 1 in all cases. So keep that in mind. When we use a standard normal distribution, we still draw the same shape, but our axis underneath, we use capital Z to represent our continuous random variable to indicate that it's standard normal instead of just regular normal distribution. Also, our peak, because we now have an actual value, we don't just write mu, we write 0. And this would be 1, this would be 2, this would be 3, so on and so forth. So on the other side, -1, -2, -3. On a standard normal distribution, the individual values of the continuous random variable are really z-scores, because remember that a z-score, and here's the formula if you've forgotten, a z-score represents how many standard deviations from the mean a particular value is. So here I'm 1 standard deviation from the mean, that's a z-score of 1. So the values are the z-scores. Just like we did with uniform distributions, the area under the curve is representing a probability or a proportion. One other notation related to z-scores and the values on a standard normal, you're going to see this notation, which we read that z sub alpha, because that's a lowercase Greek alpha. And what that represents is the z-score such that the area to the right of it is alpha. Now, this part is going to be important because that's going to be one of the major things that we're talking about today, is deciding, okay, is the area to the left? Is it to the right? Is it in between? Is it in two places? And that's how we're going to do our calculations today. So it's important that you know that when you see this notation of z sub alpha, that whatever that alpha is, that's giving you the area to the right of the z-score. So, as I mentioned, in 7.1, we found probabilities. We used area. We drew a picture of a rectangle because that's what happens with a uniform distribution. Now we're going to do the same with normal and standard normal distributions. So we're going to have a by hand approach, quote unquote, and we're also going to have a with technology approach. So the with technology, of course, we're going to use StatCrunch. Our by hand approach, however, we are going to need the table 5 from our text, from the appendix. So if you lose the copy, you can access a digital copy in the modules if you go under the course materials modules for 7.2. It has a PDF version of it for sure. But if you lose the hard copy and don't want to go there, it is in the appendix of your text as well. The reason why we have to use the table for the by hand approach is this is an introductory statistics course. Some of you I know have taken calculus, but many of you have not. And in order to find area under a curve, we need calculus. We would have to do some integration, which would not be super quick either. So that's what the table is going to be for, and I'm going to show you how to use it. So, in this section, it is important to note, because rounding rules in general change, depend on what we are talking about. In this section, when you're asked to find an area or asked to find a probability, we're going to round those to 4 decimal places. Also, their z-scores, that hasn't changed. Z-scores are still 2 decimal places. So if it asks you to find the z-score or the value of the standard normal continuous variable, then we would round those to 2 decimal places. A couple other things to keep in mind, because these are continuous random variables, the probability of either x or z being equal to a single individual value is 0. It doesn't matter what that single individual value is. We have all these values under the curve. Any individual single value has a probability of 0 because, like we looked at with the uniform distribution, the probabilities are assigned to intervals. So in a uniform distribution, the probability of falling between 1 and 3 had to be the same as the probability of falling between 5 and 6, as long as those were both in the domain. So we assign probability to an interval. It can be a small interval. We might just go from 0 just to a tiny decimal above it or below it. But in order to have a value that is not 0, it has to be an interval, not just an individual value. Because of that, all of these probabilities are equivalent. So what this is essentially telling you is it doesn't matter whether the symbol has an equal sign on it or not. It's the same answer regardless. So the probability of x being less than 10 is equal to the probability of x being less than or equal to 10, which seems kind of counterintuitive because we've placed so much emphasis on whether we include a value or not in algebra. But in a continuous random variable statistics situation, there is no difference between the two. So that's important. I have put on here the directions for how we are going to use StatCrunch, and of course I'll show you and walk you through how to do these as well, but if you forget what I showed you, it's written out here in words for you as well. So in example 1, for each given z-score, find the indicated area using table 5. Draw a picture and show your work. Everything is going to ask you to draw a picture. On concept checks, it's going to ask you to draw a picture. In the directions in the homework, it's going to ask you to draw a picture. I assume that on the final exam, these types of problems are going to ask you to draw a picture. So that is not optional. You have to draw the picture. So First example, for each given z-score, find the indicated area using table 5. Draw a picture and show your work. So I am going to indicate for you at the end of this video. I'll write it down for you and explain in addition to reviewing it in class. But there are certain problems in the homework where I'm going to say these ones you have to use the table. And then the rest you can use StatCrunch for, which, you know, takes a little bit less time. In some cases, a lot less time. So this is our, table 5 is our quote unquote by hand. So we are going to find the area that is to the left of a z-score of negative 0.43. So when it says draw the picture, it means draw, in this case, the standard normal curve. I know it's standard normal because it says z equals and not x equals. So my continuous random variable underneath is z. That's part of the picture. My mean, I know, is 0. You do not have to label all of the standard deviations, but you do need to make sure that you put the actual given value, you know, in an actual place where it would be located. So on a standard normal curve, the standard deviation is 1, which means even though I don't need to label this, that one standard deviation away would be at -1. So I'm not quite going to be to there, and I'm just going to label this negative 0.43. And then the other part of the picture is the shading. You shade the area in question. So in this case, the area that I want is that to the left of that z-score. So when it says draw it, this is what it means. So I've shown you everything you need: the curve, the label on the axis, your mean, and then just putting your given value in the right spot. Now, here is how we use the table in order to come up with this answer. So table 5 has 2 parts. It has one section where the z's on the left are negative and one section where the z's on the left are positive. So obviously use whichever table corresponds to your value. In this case, I need the negative version. So I need to find negative 0.43 on this table. Here is how I do that. I go, because negative 0.43 is negative 0.43. So I go to negative 0.4 because that has the correct tens place. And then the columns at the top are the hundredths place. So I scroll all the way over to where I find the correct hundredths place. So in this case, 0.04 or 0.03, and then where it intersects with negative 0.4, this right here is the value in question. That is the area. So I have shown, oops, that's my wrong one. I have shown my work over here by drawing my picture, and I write out the area 0.3336 because we do round to 4 decimal places, and that's the value that the table gives me. So it's pretty easy when you're asked for an area on the left. More difficult when you're asked for areas that are not to the left of the value. So here in part B, I'm going to do an example of finding an area that's to the right. So here's my curve shape. Here's my z-axis label. I've got 0 here. And then I've got, if this is 1 standard deviation, right, 2 standard deviations, 1.78 would be about right here. So I'm going to label that 1.78, and I'm going to shade the area to the right. This is what I'm looking for, that area. So here's the issue. The table And it shows you in the picture at the top, if you ever forget which way is the table. These table values are only for area to the left. It labels area to the left of this z. So I have to come up with a different way to find this area given the area on the left, because the area on the left is what the table is going to give me. Luckily for us, we've already learned about complements and that the total probability has to be 1. So whatever the area on the right is, it has to be 1 minus, so total minus the area on the left. So that's what I'm going to do. 1 minus the probability of z being to the left. And you can just write 1 minus, left area if you want as well. But you need to write something. It says show your work. You need to write something that shows me how you got the number, right? So now I'm going to go to the table with 1.78. So I need the positive side here. So 1.78, here's 1.7. And then I need to go all the way over to the 0.08. And I'm going to find where those two columns intersect. Sometimes it's hard to tell. And here's my intersection of that row and that column. So 0.9625 is the area to the left. So I find the area I want by subtracting that from 1. So 1 minus 0.9625 gives me 0.0375. And this would be my final answer. In part C, this one asks me to find the indicated area that's between two different z-scores. So, just like you will on pretty much every problem, I'm going to draw my curve. And I know this is where -1 would be, this is where 1 would be, 2, 3, so on and so forth. So -1.04 would be just barely beyond that first standard deviation. 2.76 is almost to 3, so here's 2.76. And what I want is to find the area between. I'm going to color that even a little more thick there. Remember that area is the same as probability, so what I'm really finding here is the probability of z being between, and it doesn't matter whether I have equals or not, these two values. Now, I can find using my table, and I'm going to switch to a different color here, I can find this area directly from my table. So that's what the table is going to tell me. But I want that area without this area. So my work here is going to say that I'm going to take the probability of x being less than 2.76, so to the left of that, and then I'm going to subtract out, you can see it on the picture, I'm going to subtract out this, which is the probability of, oops, I put x there and I didn't catch it, but now I did, of z being less than -1.04. So in this case, to find a between, I actually have to use the table twice. Once to find this area, and then once to find this unshaded area down here that I need to subtract. So go to the positive side of the table. I'm looking for 2.76. So here is my 2.7. And then I need the 0.06, so finding where those intersect, which would be right here, 0.9961. think. Sometimes it's hard to follow them across, so I always like to double check. So oops, I didn't do that right. See, it's a good thing I double checked. I was one row too high. It's this one, 2.7, and then 6. So crisis averted there, 0.9971 is what I'm going to use for here. And then I'm subtracting the area to the left of negative 1.04. So I flip to the negative sign, negative 1.0. So that's right here. And then 4. So 0.1492. Yep, I didn't mess up this time. So 0.1492. So subtract these two values, that's going to give me my answer. So 0.8479 is the area there. All right. Hopefully that makes sense how to use the table. Now, on example 2, I am going to show you how to use the table. On at least one of these. I'll probably do the second one since it's a left. But I'm specifically going to tell you when you have to use the table and when you can use StatCrunch. These directions say compute the following using StatCrunch. So the only reason I'm showing you how to use the table is just in case you would need to do by hand and would not be able to access StatCrunch. It is important that you know how to deal with it when we switch from a random variable of z to a random variable of x, which is what we have done here. So assume that the random variable x is normally distributed with mean equals 50 and standard deviation equals 7. So this is no longer standard normal. If it's standard normal or it's z-scores, you know that the mean is 0 and the standard deviation is 1. Here they have to tell us the mean and standard deviation. So we're going to be finding 4 different things using StatCrunch. And again, I'm going to show you how to use the table on this one as well, just so that you are aware of what to do when we have a different continuous random variable. So using StatCrunch is so user-friendly for this. And unfortunately, I can't project both my paper on my low-tech and my StatCrunch at the same time. So I'm going to switch over to StatCrunch here. And the directions for StatCrunch, there's 2 sets. There's finding the area under the standard normal curve, and then there's finding scores corresponding to an area. So in this case, we're asked to find probability. Probability is the same as finding area. So it's the first set of directions. I select stat, and I go down to normal. Why can I? Oh, calculators first. That's why. I'm like, why can I not find normal? Because I'm not on calculators. So stat, calculators, and then find normal. There it is down here. It's in alpha order there, almost. And so what I am going to do here is it gives, the default here is the standard, and you enter the mean and standard deviation. So in this case, it defaulted to a mean of 0 and a standard deviation of 1. So you're certainly welcome to check table answers with StatCrunch to make sure that they're right. But again, the work will be required on those. So I type in mean of 50, standard deviation of 7. I want the probability that x is greater than, so I'm going to switch here. Now notice, greater than isn't a choice. But remember what we said about the equals and how they don't matter right above the StatCrunch directions? So this is the same. Greater than 35 is the same as greater than or equal to 35. So I type that in, I click compute, and then I have my answer. So the only thing that you need to write down on your paper is what you typed into StatCrunch. So you didn't actually type this into StatCrunch because that's not possible. You typed this. So you need to write that down, and then you can write the answer. Rounded to 4 decimal places is what we need to do there. So if I flip back to see, it's 0.9839, and then it's a 3, so it does not round up. So 0.9839 is going to be my answer here. All right, so if I go to then do less than 45, all I have to do, I've already got the mean and standard deviation, switch it to a less than, switch my number to 45. What I'm writing down in this case is actually the value. Click compute, and I've got 0.2375. So, pretty easy. The StatCrunch ones will go really, really fast. Now, we are going to have to draw the normal curves for all of these. So here, be careful. Now my random variable is x. My mean was 50. So greater than 35. 35 is a little less than 2 standard deviations away, so it's pretty far down here. So 35 would be here, and greater than would go this way. On here, again, my mean is 50. My continuous random variable is x. 45 is obviously not even a standard deviation away, so it's about right here, and to the left is where I would shade. So still doing my pictures. It does tell you in the directions to do that. Now, I told you I would show you how to do this using the table. The table is for z-scores. So in order to do these by hand, you have to actually convert your x random variable to a z by using my z-score formula. So just write out here to do with table. So first I find the z-score. So x minus mu, so 45 minus the mean, which is 50, divided by the standard deviation, which is 7. So in this case, -5 over 7. Remember that z-scores are rounded to 2 decimal places, and that's what my table is based on. So -5/7 rounded to 2 decimal places is -0.71. So to do with the table, this is the value I would have to put into my table, -0.71. Obviously, this one is to the left. You would do, if it were to the right or between, you would follow the same processes that I did in example 1. So if I go to -0.7, so -0.7, and then I just need a 1 here, that gives me 0.2389. So this one right here. So notice that 0.2389 is not the same as what StatCrunch gave us. So I want you to keep that in mind, that, if you're doing any of the odd numbered problems and checking the answers in the appendix, any odd questions, you might have a little bit off, and it's because of the rounding. It's because of this right here. I had to round that z-score to 2 decimal places, but the z-score actually had a lot more, so it causes it to be off by a little bit. The StatCrunch answer is the more accurate answer because it can do all those calculations. It's not limited by just 2 decimal places. All right. So now I'm going to go back to StatCrunch for this one. So this is a between. So we haven't done one of those yet. So for between, I click on between. And I still have the right mean and standard deviation, but I need to enter my parameters. So in this case, it says between 38 and 55. Now again, it doesn't give you an option to change these symbols because you don't need to. So on my paper, when I'm using StatCrunch exclusively, notice it's giving me the picture, right? So that can help you. So I know my mean was at 50, my variable is X. So between 38, which is several standard deviations away. So 38's about right here. And then 55 is a little less than one standard deviation above. So 55, here's my shaded region that we can see and include. So I've got 0.7192 as my answer. Remember that I want to write out what I actually used in StatCrunch, and in this case, this is what StatCrunch actually said, and my answer was 0.7192. All right, D, the 9th percentile is what I'm supposed to find. So it doesn't say probability of the 9th percentile, it says the 9th percentile. So going back to how we defined percentiles, when you have a percentile, what that means is that the area or the number of people below you is whatever that percentile is. So 50 is the mean in this case. The 9th percentile is going to be way down here, but it's not that this is 9. The 9th percentile means that the area or the probability is 0.09 or 9%. So in this case, when we draw our picture, we say area equals 0.09 because that's 9%, instead of labeling the X values, because the X value is what I'm trying to find. So what value of X would be considered the 9th percentile? That is super easy to do in StatCrunch, but it's working backward. So this is not a between area, this is an area to the left. Obviously, even if it's a percentile, you know, you have to adjust. It's area to the left that I'm always using on this. So I click back on standard. And so I want to know what X is when the area is 0.09. So I'm typing the percentile written as a decimal into the area, so the rightmost cell, and I've got it on less than in this case. So compute, and notice it fills in the value for me. So this value, it doesn't really say what it's representing. If we knew what these were representing, we would know what to round to. Because we don't, I'm just going to take it to 2 decimal places. So what I did is I did probability of X less than or equal to blank equals 0.09. And it gave me 40.61 approximately. So 40.61. So the only work I need is to know what you typed into StatCrunch, which was this. And this gave me my answer. All right, hopefully that seems easy enough to find those probabilities, to find that value. Now we've got a couple that are just worded a little bit differently. So example 3, find the z-scores that separate the middle 90% of the distribution from the area in the tails of the standard normal. So draw the curve. That's going to be pretty much on every question. So I draw the curve. What the picture is saying, and it's standard normal, so I label it Z, is that I want the middle 90%. So most of the curve, this is going to be 0.9, because 90% is 0.9 as an area. It's saying find the z-scores. So meaning this and this are what I'm trying to find. The z-scores that separate the middle 90% from the area in the tails. Now, it would be super helpful to know the area in the tails if you were doing this using the table. So if 90% is used, that means there's 10% left. Because it's symmetric, that would have to be divided evenly. So knowing that each of those is 0.05 would be important. So to find this z-score, the quickest way to do that in StatCrunch is to type in, just like we did on the last one, the area, but be careful, it's standard normal. So mean is 0, standard deviation is 1, and I want 0.05 as the area to the left, right? And I click compute, and then it gives me the negative 1.64. So negative 1.64, what I pressed into StatCrunch was, switch back over, probability of x less than or equal to blank equals 0.05. So that's how I got that. There are several ways to get this other one. I could, if I wanted to type less, leave the area and switch it to a greater than or equal to, and click compute. Oh, it didn't, never mind, that didn't work because it changed the area there. If I deleted the middle, it would work fine. So if I make this 0.05 on the right, so greater than, and click compute, it gives me the answer on the other side. And you can see it again in the picture. So this one, I did probability of x greater than or equal to blank equals 0.05. You could have also, instead of doing 0.95 here, you could have kept it less than or equal to, but switched it to 0.95 and see how that gives you the same answer. So it doesn't matter. There can be different ways to come up with that using your StatCrunch. All right, next one, example 4, find z sub 0.01. So making sure that we know what that is asking. Back on the front, we said that that represents the z-score such that the area to the right is alpha. So the picture here, my continuous random variable is z, and I know this is 0. It says the area to the right is going to be 0.01. So it's a very small area. That's how I know it has to be over here, because anything this half, the area is 0.5. So I know where it's located. It's really small. This is the z sub alpha that I'm trying to find. I'm trying to find that value. So this also is a working backward type. So in StatCrunch, mean 0, standard deviation is 1. I'm going to do greater than or equal to. I'm going to leave this blank because that's what I'm looking for, and I'm going to type in the area 0.01 and click compute. And it gives me 2.326, so to 2 decimal places, since it's a z-score, would be 2.33. So again, what did I press into StatCrunch? I did greater than or equal to blank equals 0.01, and I got 2.33 as the result. Okay, so last one. Now finally, I've taught you all the different situations, at least I hope so, that you can encounter. So it's important to be prepared for everything. Area to the left, area between, area to the right when I'm working backwards. So that's why we have so many examples, because there are so many different things that can happen. So example 5, we're finally getting to a real life situation. The lengths of human pregnancies are approximately normally distributed with mean 266 days and standard deviation of 16 days. So automatically, because I know I'm going to have to draw that curve, I have to draw it on pretty much every question. In this case, it does not have mean of 0, so my continuous random variable is x. My mean is 266. My standard deviation, it says, is 16. So this would be 16 above, 16 below, so on and so forth, continuing to work our way out. The question asks, what proportion of pregnancies lasts more than 270 days? So 270 is slightly above the mean. So if I'm going to mark it, maybe about right here, and more than means above, so when I'm drawing the area under the curve, I'd be shading to the right in this case. Again, there are only a select few that I'm going to require that you use the table, so we can use StatCrunch here, and what I'm going to type into StatCrunch is the probability of x being greater than or equal to 270, obviously with this mean and standard deviation typed in. So I go to the mean, 266, to the standard deviation, which is 16, and I want the probability of greater than or equal to 270. Click compute. And it gives me 0.401, and then it rounds up, so a 3. So 0.4013 would be what I would write here. Because remember, proportion is just like probability. That's what area is finding. Notice the difference in the wording from part A to part B. This says what proportion. This one says if a human pregnancy is randomly selected. So we talked about this in 7.1 and the different interpretations that these areas give us. So we're still going to do the exact same thing. It's just that what the wording of what we're asked to find is a little different. So I'm going to draw my curve again, just like on every problem. I know you're going to get really tired of it. I'm sorry about that. So 266 and our standard deviations. We want to know the probability that a randomly selected human pregnancy less than 250. 250 happens to be exactly one standard deviation, and less than is obviously to the left. So in StatCrunch, I'm going to be doing the probability of x less than or equal to 250. So I switch back over there. So less than and 250 compute. So I get 0.1587 if I round it. So 0.1587 to 4 decimal places would be my answer. Now, this is a good opportunity to notice that the empirical rule is pretty accurate here. StatCrunch is using sophisticated programming and calculations to get a very exact answer. The empirical rule is an approximation that tells us that if it's normally distributed, that about 68% falls within one standard deviation, which means that this would be 34% approximately. Everything to the right of this would be 50%. So 86% leaves 16%, and look how close 16% is to the exact StatCrunch answer. So that empirical rule would get us something really close, just wouldn't get us to 4 decimal places. So that just gives you more love, hopefully, for the empirical rule. Part C, what proportion of pregnancies last between 240 and 280 days? So draw our favorite curve. We've got 266 here. One standard deviation is 250. The standard deviation is 15, so 240 is not 2 standard deviations away, but it's almost. So this is where approximately 240 would be. 280, if I do 1 standard deviation above and adding 16, that gives me 282. So it's going to be just below that first standard deviation. So 280. And here is the area in question. Because I can use StatCrunch, I can flip it so that it's a between value. So I can actually type it in exactly like this to my StatCrunch. So click on the between, in this case, between 240 and 280. Click compute, and it gives me my answer, 0.7571. So 0.7571. Again, please keep in mind that if you are checking answers with the appendix, that they may have done it using the table, and the answers might be slightly off. We are using StatCrunch for everything except the ones I tell you to. So your answers should match my answers, is what I'm saying there. Almost there, guys. I know. I'm sorry. What is the probability that a randomly selected human pregnancy lasts no more than 245 days? So 266 is my mean. I know that 1 standard deviation below is 250. So 245 is about right here. So 245 is labeled, and no more than means that amount or lower. So probability of X less than or equal to 245 is what I'm finding here. We're just making sure you can use the correct notation. So I'm going to switch 250 to 245, click compute, and I've got 0.0947 because I'm going to round that 6 up. So 0.0947 is your answer. Last one, a very preterm baby is one whose gestation period is less than 224 days. Are very preterm babies unusual? So with our mean of 266, 224 is going to be below 2 standard deviations. So maybe about right here-ish. So less than, so shading to the left. So probability of X less than or equal to 224 is what I need to find in order to be able to answer the question. So less than or equal to 224, compute. That gives me 0.0043. So unusual, remember, is 0.05, anything that's below it. So we would say yes, because the probability of very preterm is less than 0.05. All right, Sorry that this was lengthy. I really tried to limit it, but I have to show you all the situations. So, on the homework, I told you I would adjust those a little bit. So what I want you to do is to do 1 through 4 still. That's all. So 1 through 4. You're going to go from 6 to 28 even. But here's the deal. 6, 8, and 10 must be done using the table. You only have to do parts B and C on those ones only. Everything else, you'll do all the parts. But 6, 8, and 10, I want you to use the table. You need to show your work. You need to write out everything. But you only have to do parts B and C for 6, 8, and 10. Then after you finish 28, you're going to do 36, 38, 44, and 52. 52 is a really nice, pulls in some older stuff from StatCrunch that we want to make sure we don't forget. So there you go. And let me know, of course, if you have questions.